So I would just like to take this opportunity to say thank you to all of our speakers. This has really been an excellent conference, and this is the very last session. We are rounding this out with a panel discussion. And our panel is the benefits and pitfalls of using AI in research and scholarship. And I believe what I will do is I'll go ahead and just start with I'll read the bios of the speakers, introduce the speakers, and then we'll go ahead and get started with the panel. So on this panel, we'll have Dr. Patricia Jones, who is an Assistant Vice Chancellor for Research and Innovation and Compliance at the University of Illinois Urbana-Champaign. In this role, she oversees the university's compliance programs in research safety, animal care and use, and human subjects research. And she also collaborates with UC's Research Integrity Office to provide training on the responsible conduct of research. She also serves as the chair of the research working group of the university's Generative AI Solutions Hub. Previously, she served as the Associate Director for Research at the Beckman Institute for Advanced Science Technology at UIUC, and before that as a Deputy Director for Exploration Technology at NASA Ames Research Center. She earned the BS degree in psychology from UIUC and the MS and PhD degrees in industrial and systems engineering from the Georgia Institute of Technology. And I'd also like to introduce Dr. Jonathan Mintz, who is an assistant professor in the Industrial and Systems Engineering Department at the University of Wisconsin-Madison. His research focuses on the application of artificial intelligence and automated decision-making to human-sensitive contexts. One application of his research has been on using patient-level data to create precision behavioral interventions. Jonathan is also interested in the socio-technical implications of AI algorithms and has done work on fairness, accountability, and transparency in automated decision-making. In terms of methodology, his research explores topics in machine learning theory, stochastic control, reinforcement learning, and non-convex optimization. And prior to joining UW-Madison, Jonathan was a postdoctoral research fellow at the Department of Industrial and Systems Engineering at the Georgia Institute of Technology. And Jonathan received his BS in Industrial and Systems Engineering with a concentration in Operations Research from Georgia Tech in 2012, and his PhD in Industrial Engineering and Operations Research from the University of California, Berkeley in 2018. So thank you both for being here. And we're also expected to be joined by Dr. Soren Matai. I'll read his bio here, who is the College of Liberal Arts Associate Dean of Research and Graduate Education and Professor of Communication at the Brian Lamb School of Communication at Purdue University. He studies the relationship between information technology, group behavior, and social structures. His current interests focus on modeling and simulating the role of communication and information processes and collaboration and conflict, spanning from knowledge production to military command and control. So thank you so much for being here. I apologize, my lighting is not the best. I just switched offices and now I'm just dealing with all of those changes. So what this panel will look like, what will allow you each to talk about your own work and just kind of talk about the use of AI in research. And then I have some prepared questions, but those of you who are interested in also asking the panelists questions, please do so in the chat and we'll get to your questions as well. So why don't we start with you, Dr. Patricia Jones. Tell us about your work and the use of AI in research.
Well, thank you very much. I'm not an active researcher anymore. I'm now an administrator, but back in the day, I was focused on the question of human supervisory control of automated systems. And so I see a lot of interesting groundwork that was laid in those ancient times that applies to generative AI today. So the research interest at the time was how to develop intelligent decision support and training systems that kept the person in the loop and kept them well trained and had a good concept of operations, but also took advantage of current capabilities and technology to support effective and efficient use in safety critical systems. So I did a lot of my work in different missions related to NASA or or air traffic control or flight deck, that kind of stuff. And there was always this interesting question of, sure, you can automate something, but what is the proper balance of work between the human and the automated systems, or how does a team work with a human with an automated system? What is that function allocation? How can you design it, but also how can you have it be flexible using, quote unquote AI technologies. So there's always this question of what's the appropriate ethical use for having a person with having a good job and having understanding and being able to engage when emergencies happen, but also how do you become more efficient and effective? And I'm sure that's probably leading into Dr. Mintz's discussion as well.
Great, thank you. Dr. Mintz, would you like to talk to us about your work and use of AI in research?
Sure. And also, it's, I feel like running into fellow industrial engineers in the wild is pretty rare, and also with the Georgia Tech connection. So it's good to see some representation. But yeah, so the focus of my work, as you kind of heard from the bio, has really been on looking at cases where we have high fidelity data for individuals and we're trying to make some fairly risky decisions. So you might imagine this comes up a lot in healthcare. If we're trying to come up with a system, for instance, where we're figuring out what the right amount of drug to use as a dose for a patient in the ICU, the same algorithms that we're going to want to deploy there are probably not going to be the same ones that we want to make to serve ads, for example, on a website, right? If we make a wrong decision, it's going to result in adverse effects for the patients, maybe even death. We need to be really conscious of what the decisions we're making and how we are viewing the risk associated with it. So kind of looking at all this stuff in applications in healthcare, it kind of led me to doing some more interdisciplinary work. And I've actually worked with ethicists and a few policy people on kind of more broad AI safety topics. I gave like a university lecture that was then on like PBS a little bit about this work. But really the idea was thinking about sort of the design process from the top down on how we can think about, okay, where are issues of safety going to be interjected as we design the process, right? You often hear a lot of people say, oh, if only I had more training data, if only I had, more time can spend on compute, I'd have the greatest algorithm in the world. It'd be totally safe and we wouldn't need to worry about anything. But realistically, right, algorithms are just tools that are designed by people. People are flawed, and we really need to think about, what are we introducing in the system, right? Kind of almost like a Swiss cheese style approach, if you will, if we take some kind of like the human factors or cybernetics type thinking about it. And right now, I'm really focused on not just that, but thinking about, as we have sensors around us in daily life, as we're interacting with generative AI, and AI technology is like democratized, right? Now everyone's able to chat with ChatGPT. Number one, what does it mean, in terms of making sure that we're interacting safely with users? But number two, how do we actually harness this to help people live healthier, better lives, right? Technology is sort of the best we can make of it, and seeing how we can integrate this in other aspects of the work.
Great, thank you. So there was a question that was put into the chat. It's a bit of a policy question. So where does the panel see the responsibility line within a university/system? So for example, UW system versus separate institutions like UW-Mass and UW-Milwaukee. And then within the university leadership for developing policy, guidance, training, and enforcement and use of AI in research. And how does that responsibility differ from the use of AI in scholastics? The very first question. And then the follow-up
I can speak
question.
for that since I am an administrator on a campus level, but of course our system people are also largely here in Urbana too. So like if, as Chris Mulleyman, my colleague here might have told you all, our link to our University of Illinois policy on research integrity and publication is a system policy. So we all like point to that. And then when it gets to the procedures for how we do a misconduct investigation and that kind of stuff, that is like a campus thing. So that's where Chris has written our current like lower level policy and procedures. For something like Gen AI, we don't have a specific policy per se. And as you mentioned in my introduction, I'm the chair of the research working group of our generative AI effort on campus, which is called the Generative AI Solutions Hub. It's genai.illinois.edu. I'll put that in the chat. And so we initially were charged to come up with best use cases, then best practices, then policy. and then other stuff about community building. And so we have use cases and best practices on the website, and we haven't really gotten to policy per se, because to me, for the research side, a lot of what we do is really falls under the general policy for the responsible conduct of research. So being honest, transparent, accountable, taking responsibility for your work, whether it's a statistics package or a computational model or generative AI, you still have an obligation to understand its parameters, know the inputs and outputs, be able to explain it. So to me, Gen AI is just a special case of that kind of thing. And so we haven't elaborated a huge amount on that sort of thing. And then for publication ethics, I have pointed to Elsevier, Springer Nature, IEEE. You know, our system policy says that you should do it with, you know, your own discipline and your own specific context of research and scholarship. So I think that in general, we would have really high level stuff at the system, and then we sort of implement it more specifically at the campus. The same thing is true for PIPL, the Chinese privacy law. We have general guidance at the system level, and then now we are setting up a committee right now to do research oversight of PIPL related stuff.
And then as a follow-up question, what is the current state of the art and policy leadership on this subject with the national leaders?
Well, I've been tracking a number of things. You know, there was the White House executive order. I've been looking at the NIST AI risk management framework, which has a lot of general stuff that would be relevant for kind of any technology, but then it has a bunch of stuff related specifically to generative AI. So for instance, there are specific concerns about generating information related to chemical and biological warfare, to pornography, to hostile and racist text. So there's going to be certain things that are specific to a generative sort of AI, but then more basic questions of security, privacy, and that kind of stuff would apply to a lot of different sorts of IT systems, even whether or not they're even artificially intelligent. So I've been trying to track a lot of this stuff, and then what I've been doing with Chris is we have presented a generative AI like little capsule presentation as part of our responsible cognitive research speaker series here at Illinois, and then I'm also teaching a class on the responsible cognitive research, and I'm going to spend a lecture. It's only a 1 hour class. So it's like lightweight for people to get into. And my whole point is to help students get the right mental model of how to think about research ethics. And so one of my lecturers will be on generative AI specifically. And a lot of the stuff that we have all seen today is similar to what I have already harvested from other websites and other readings and stuff. And I have a whole big library of stuff on my team site for our campus team as well.
Dr. Vince, did you have anything to add for that question?
Sure. I think, like Patricia said, I was reading the executive order when it came out last year. Obviously, we'll see what happens given the events of last week, where things are going to go. Right, we're all waiting in anticipation. But I would say that as things stand, I think things are pretty vague, and I like that Patricia was mentioning some of the initiatives that they had because at the moment, AI seems like a very nebulous term that encompasses lots of systems that go from ChatGPT to recommender systems to all sorts of technology that are out there. All of them are used differently. Something else that I'd like some of the attendants to think about is the difference between, you know, research that's fundamentally about AI and like the development of AI methods and AI models versus like the use of AI, right? We can use ChatGPT to help us with readability, like we saw in the example of the previous presentation. Think about it as an extension of, you know, like almost a spell check, right? But plus plus, essentially. That's quite different, right, from someone that's developing like a new system, and you're going to have different regulations, different ways of thinking about what the ethics of research are that are involved, depending on the two different approaches here.
That's a great point. When we've been developing our next concept for generative AI service center or some such thing on campus, a lot of the initial impetus was on, you know, how to use AI ethically. But all of our researchers who actually build AI systems are like, well, we should also be looking at supporting bleeding edge infrastructure for us to develop new things as well. So we want to kind of do both things of support technology development, but also look at its use more broadly as well.
Great, thank you. We do have participants here who are graduate students, maybe early career researchers. So what do you think them and the next generation of researchers should know about using AI in research and kind of both of these facets, either using it, as you just mentioned, or even just developing different platforms?
Well, developing different platforms is that's a whole PhD program right there. So maybe I'll focus on using it for now. Um, but in terms of using it, I think it's really important to know, like Patricia said, like with any tool that you use, what are the parameters, what are the capabilities, what are not the capabilities. I've seen seasoned researchers write preliminary proposals that I've helped review for them, where they wrote numbers and then sourced them to ChatGPT. And I need to remind them that ChatGPT is not meant to make projections of numbers. It's just a text generation algorithm. The end of the day, right? You're responsible for using the tool. You are the final QA on what gets produced, right? And I know there's been a lot of talk on using AI for authorship, something that I personally find concerning, and I hope young researchers and people coming up don't do, is using generative AI tools for text summarization and then reviewing papers based on summarized text. I think that's a gross violation of ethics, right? Us as academics really need to sort of take pride in our reputation, right? We're experts in our field. The commitment that we make is if we give a review, if we submit a work, right, that's the best work, and we've checked it to the best of our abilities. Any level in between that causes some interference.
Dr. Jones, did you want to add anything to that?
I was just waving to Soren. Hi, Soren.
Hi, how are you? I apologize profusely for stepping in in the middle of the meal. I'm in Central Time, and somehow, my calendar did not align right. I'm sorry, but I would like to participate with the conversation if you allow me to.
That's fantastic. Yeah, we're talking about what advice would you give to grad students, and I think I was just going to echo what Dr. Mintz said as well, that you're using a stats package or a computational modeling tool of some sort or a generative AI thing, and whatever it is, you're still accountable and responsible for understanding what are the boundary conditions using this tool, understanding its inputs and and to some extent how it generated its outputs, and being able to explain that in some fashion. Now, there are limits to that, just like a pilot may not be able to explain how does my traffic collision avoidance system algorithm work on the airplane, but you kind of know what it's doing. So to me, there's an interesting question there of intelligible AI and how intelligible do you have to be. But anyway, I would say that you need to have some level of understanding of the appropriate use for which the tool is built and use it in that manner. Or if you're going to do something, you better and of course, disclose whatever it is you're doing.
Great, thank you. And then Dr. Matai, welcome. We're just talking about the question for graduate students. What do you think the next generation of researchers should know about using AI in research?
Yeah, thank you. Well, first of all, by way of introduction, Soren Matai, professor of communication, social science, computational social science, as is my area of interest at Purdue University. And I've been interested in models and modeling for a very long time. I take machine learning and deep learning and generative, systems to be an extension of predictive models. And in that respect, we need to think about the things we already know and, kind of try to converse with these new technologies in a way that keeps track of what they've added to what we know, and also be mindful that some of the claims made about them might not always be justified because they have a past and they're not as brand new as they seem to be, right? It's very, very important that we do not venture too far and in the realm of speculation when we think about, especially about generative models, right? Without reminding ourselves constantly that deep learning models and neural network models are predictive models. By the end of the day, there are some limits to what they can do, right? And they are sub-symbolic systems, predictive stochastic systems. And, they cannot do the other things that we thought that artificial intelligence could do, that McCarthy and Minsky thought they could and should do, right? Which was, this type of higher level, deductive, truly creative thinking, which we figured we could not do with the tools we have left behind and switch to what we can do, right? Which is, again, is predictive stochastic models, which is cool and wonderful, but it's not, the end of the road by any stretch of the imagination for us as humans and for science. And I can say a few more things, but, just by way of introductions, this is who I am and what I think. I'll stop here.
Thank you. Okay, so we'll move to next question. There's a lot of talk about having accountability and knowing the limits of different tools, and AI is moving so quickly, it seems. So how do we learn not only about what is all out there, but also learn about the potential implications of using it?
Well, I think we already mentioned that there's some high-level frameworks that can be helpful for us. So there are a number of different bodies that are looking at equal AI or ethics AI. I've looked at the fairlytrained.org website. Like it's meant to say, if you want to train your AI on data, we can make sure it's curated and fairly available for you to use, for example. So I think there's like cool things like that are out there, but I haven't really used them and I don't know a lot about them. But I think over time we're going to see more governance through the European Union's AI Act, or like I said, the NIST AI Risk Management Framework. And a number of things like that. And I also think it's really interesting how the publishers are explicating these kinds of things for looking at authored publications. So I think that there's a lot of different things happening also in the kind of the regulatory or compliance kinds of spaces.
So in our paper on hard choices in artificial intelligence, we kind of talk about this a little bit because it's really important to think about AI in the context in which it's deployed, who's the end user, who's the developer, and what's going on. There's been a lot of focus on, fairness and prediction and different sort of metrics, but that only gets us part of the way, right? Even if we develop a model that, let's say, is like fair with respect to all predictions, doesn't mean that the model is actually performing what we want it to in the end. It doesn't necessarily justify having it out there, right? And especially as models start becoming more integrated as part of the infrastructure, right? If we imagine more and more systems being automated, it's really going to take a lot of work of thinking about what's happening in each individual context. There's never going to be a moment where you could be totally abreast, right, of every single possible AI model and every single thing it's possibly doing. That's right, true for any technology in any part of science, right? Like, but we have people that specialize in designing these systems. Just like, not all of us are mechanical engineers and need to completely understand how the cars work in order to be able to drive them from one place to another. Just having, basic knowledge of, okay, minor integration, that's going to be good enough. I don't think there'll ever be a time where all of us need to be experts. And I think it's really critical that we think about, okay, what's the system designed to do and how am I interacting with it as a baseline to start and figure out how we want to think about it.
Yeah, if I may say something about this crisis of explainability at this point, would this be a good time to address this issue?
Please.
Okay, because we talk about explainability in various ways, kind of going around it. But let me put it this way. And I'm inviting my colleagues in STEM here to think with me. Maybe I'm wrong, but maybe I'm onto something. To me, the crisis of explainability in neural network models, especially, right, which are the infrastructure of large language models, which are the infrastructure of what we call AI systems, right? So the crisis of explainability, our perceived inability to explain how classification decisions for discrete classification acts are made, right? It's very similar to the crisis of explainability that physics has been through when it switched from classical mechanics, Newtonian mechanics, to quantum mechanics. And the crisis is, encapsulated by the idea that in quantum mechanics, you are actually not predicting anymore where a particular particle is. You cannot do that. The tools that you have built are not meant to do that. Actually, the basic assumption is that there's a certain degree of unpredictability, right? There's the uncertainty principle, right? That actually the old model that we had for the atoms, right, which are surrounded by electrons that move on these orbits and all that, like planets, say it's wrong. That's not how atoms work. There are levels of energy and clouds of probable presence of certain quanta, right, that we call whatever, right, that we can measure and we can estimate, but we will never be able to precisely, in a Newtonian sense, explain, right? And we are fine with that. Why? Because this new physics, quantum mechanics, allowed us to come up with new ways to measure and create new tools that work perfectly well, despite the fact that we cannot explain them to a T by the rules of Newtonian mechanics, right? We do have explanations for them, but not Newtonian, right? I think that this is our problem with explaining how a classifier does what it does. In our, struggle with trying to fit the square peg in a round hole, right, of deductive models, deductive predictive models, is unproductive. And actually, it's a false crisis. I think it is a false crisis. We are inventing a crisis, if you want, right? Because we refuse to accept that we have created a new way of getting at, reality that has trade-offs, has built-in trade-offs. We give up some certainty for more and higher precision, actually, right? And, trying to kind of backfit this into a very traditional computational model, right? Where you imagine that you can document the code, right? And write at every instance, this does this and this and this, and then defend that in the court of law. It's just not feasible, and it's not productive, and it's actually not real. In a way, the people who should know better about this should not come after explainability the way they do, right? They like it because this gives them some sense of control over the thing. But at the same time, it hides from the public and from ourselves what's at stake, what's really at stake.
So I'm no physicist, so I'm not going to speak to the analogy. I did industrial engineering because I hated integrals, so I stuck to only discrete math, unfortunately. But I will say, I think it's good to focus on neural network models, because when we focus on simpler models, right, like when we look at stuff like decision trees and we look at simple linear models, we can clearly say why the classifier is putting one class in a particular area and a different class in another area. Now, explainability, I think, needs to be kind of more rigorously defined, right? What do we mean by explainability? Is it understanding rudimentary, what's the mapping from inputs to outputs that's making a certain set of inputs give us one class versus another class? Or are we talking about coming up with a deductive reasoning structure, right? Those are two different things in my mind. Having a model that's able to classify, right? We have methods like SHAP and LIME that kind of give us a high level idea of what's contributing to a particular classification going in a specific way. They don't tell us why the model is reasoning the way it is, why the particular pattern was done in the model, right? And there's work that's kind of been put on the sideline for now, but some people are still investigating, right, in terms of theorem provers that are actually doing deductive reasoning. But I think it is important, right, kind of like what you were saying, Soren, to remember that with these high capacity models, especially LLMs, it's not deductive at all, right? It's pure inductive reasoning of exactly what's happening, right?
100%.
And the real crisis, in my opinion, is like kind of similar to what you were saying, really coming more from like the human element, right? Like a pareidolia of how people interpret things. There's a study that came out earlier this year where folks took a bunch of medical cases, fed them to ChatGPT, or GPT-4 to be specific, to ask it to provide a diagnosis for certain patients. And in addition to providing a diagnosis, they also asked it to give a short write-up about why it provided the diagnosis. Then they showed the reasoning and the diagnosis to clinicians. And I believe like not an insignificant amount, something like 10, 20% of the clinicians thought it gave a reasonable explanation. And like 5% of them even said, that's a better reasoning than what I give, right? To me, that's scary, right? ChatGPT isn't actually giving an explanation. There's no real explanation for why it gave the diagnosis that it did, right? There is no reasoning. It's pure induction. The text that was generated was the most highly likely text to come after the particular case that it was given. It's not that it was truly reasoning about what it was saying, and yet, right, through the human interaction, these highly educated clinicians kind of deluded themselves into thinking that this is sort of what the model is doing. And I think this is the kind of difficult thing that we're going to have to train ourselves out of, and realizing that when we are dealing with induction, we can't assume the same theory of mind that we assume that we talk with another human being, right? There is no internal monologue. There is no true reasoning that's happening. And we got to take it almost at face value. And I think that's really difficult if you're not as familiar for how to interact with some of these systems.
Oh, absolutely. I mean, ChatGPT is the ultimate mechanical Turk. It is the mechanical Turk with no human inside.
This is a great conversation. It reminds me of a couple of points I was just going to put in the chat here. One is the question of, are humans, like, do we just have the willing suspension of disbelief? Why do we cry when we see a movie, or why do we laugh and read a book, or why do we fall in love with a chatbot? It's like we know it's not real, but we are still affected by it. So to me, that's one interesting element of this kind of thing about why do we believe things. The other interesting element that I'm curious to think about is this like a really American thing? Because Neil Postman's book Technopoly talks about American culture as really uniquely not just a technocracy, but a technopoly. And I wonder if like it's only in America that this kind of stuff could happen because of the way that we construct and believe things about the importance of technology and how cool it is that we can do something with tech. So those are my quasi-philosophical thoughts here.
There any responses to that kind of philosophical question about America perhaps being different in that way about how we do?
And I don't know if we can go there.
Yeah. I mean, it is true. We think about all the different startups and companies and so on and so forth. That is something that is quite uniquely American. So there is another question that perhaps kind of can be related to this a bit is, have you encountered any stigma in using AI in your research, either from journals or organizations or maybe different colleagues?
I would say no.
Yeah.
I was going to say our campus here seems pretty pro, even though we have had a couple of different faculty meetings where people have said, dystopia, Terminator, death of humanity kind of stuff. Mostly the atmosphere is cautious optimism that we can see the value of things. Like I put in the chat earlier during the other sessions, U of I, Urbana-Champaign has its own chat bot that you can upload all your stuff to and talk to your data. And we have Microsoft Copilot licensed with data protection for our university, and we're going to be probably doing the Zoom AI assistant as part of our license soon. So like there is a process to say we're going to do a security privacy check on these technologies, look at the licensing terms and conditions, and then we will deploy things. And then it's still sort of an open thing about how we are meant to help govern all this stuff. And that's why I'm on this Generative AI Solutions Hub, which isn't really a policy-making body, but it's kind of an advisory thing to our Chief Information Officer and our Vice Chancellor for Research. And in that way, and we have a lot of people from our library that are on this, so we have great people from digital humanities that are part of this conversation too. So I think we have a lot of good people here that can help make good things happen, but it's still kind of a very sort of open system right now.
Yeah, I think when I was doing my PhD, there was a lot more skepticism around automation, especially when it came to sort of medical decision making, especially, and even right now, right, and I think rightfully so, right, like when we write grants for like the NIH, we have to be fairly conservative with kind of like what we're doing with the technology and how we're selling it, for lack of a better word, in order to make sure that we can actually get funding. But I think what's been kind of more alarming to me, which I sort of didn't think about it, is how less stigma there is of AI out there in the world. There's a lot more techno optimism than I previously expected. I was giving a talk at a conference for internal medicine physicians, and all of them are, ready to automate so much of their jobs to the point where I was like, all right, maybe it's time to, learn how to suture my own wounds. But I, so I think we might want to think about uh, reeling some of that a little bit back, right? And thinking about, again, more of the limitations, right? We should avoid, I think the Terminator talk, I think, is a little bit silly, but I think there's like, some realistic short-term things that we all need to think about that we need to avoid as we sort of discuss limitations of automated systems and sort of the responsibility of practitioners and especially academic professionals, other professionals, right, legal, medical, and how we want to carry out using automated services for doing our jobs and our responsibility.
Dr. Matai, do you have a comment on that question?
I would like to say something about this too. Remember the pandemic when it hit us and closed us, cooped us in our houses, and we all switched to Zoom, right? And we all started doing Zoom, and we're doing Zoom now all the time. How long have we had access to Skype, Zoom, and all that before the pandemic hit? I don't know, probably at the very least 5 years at high level of proficiency. So all these tools were available there, right? Zoom was a thing. I remember using it on and off for very bizarre reasons and not giving it a second thought as a main means of communication. Actually, it was more like of an encumbrance. And all of a sudden, the pandemic hit, and now we cannot live without this, right? I think that the basic models and procedures behind ChatGPT, again, which is these neural networks and machine learning and all that, are on the cusp to become, the video conferencing of our era, because now we realize all of a sudden, now that we understand how it works, that we can apply it to so many other things and we can do so many other things with it, right? I expect a great wave of soul searching enthusiasm for machine learning finally, eventually, right? Especially in areas where people did not think much about it. We've been talking in online education forever and a day about interactive assignments, right? That change with the level of skill and need of the learner, right? That should be a duh thing, right? With the tools we have today, right? Kind of pulling students out of the routine of reading the same assignments, taking the same quizzes, and doing the same things all the same because it's easy to do. It should be trivial, and online learning could become so much more interesting and accurate, right? Grading online assignments in a variety of ways could become so much better, right? So not to speak of other things that we can do in science. So I think that we are on the cusp of realizing that these tools are really interesting tools that can be used in a much more deeper and for many other things than the things that we thought that they could be used. And I think ChatGPT is just a way to wake us up. I don't think that we will end up embracing ChatGPT as the be all end all thinking brain of the humanity. We know and we'll realize more and more what the limits are, right? But we will see that behind it, there are things, procedures, tools, techniques that could be expanded to many other things that will lead us to very interesting new applications.
It's interesting you mentioned individualized instruction and context-sensitive instruction, because I think that is fantastic. And I think the same thing is true in healthcare, right? Personalized medicine and having a deep understanding of each person. So on the one hand, these AI technologies can bring together so much data that maybe that is helpful for making a specific prediction for a specific person. But on the other hand, ChatGPT right now is terrible when you ask it to, write a biography of somebody, right? So it seems like there is this sort of juxtaposition of extremely general, broad knowledge from a huge corpus, but then it's also really fantastic to think about how to deploy technology for these kind of very personalized ends, whether it's education or health.
So speaking of that, well, we're talking about rapidly advancing technology. We were now kind of new ways of thinking about how we're using these large language models is how do we integrate them into sort of more classical AI applications where we'd normally need someone to interact with. So for instance, you're mentioning ChatGPT being broadly bad at writing biographies. So new functionality that has come in is something called RAG, which is basically context-aware generation. And the idea being you integrate a document retrieval system into the large language model. So you give a query to the large language model, it turns it into a vector representation, numerical representation. The document retrieval then finds relevant context and then uses those passages to reinforce the prompt that it then delivers back to you the message. So now ChatGPT is actually able to search the web for, like, let's say, specific biographies, give you from the top couple search results that it obtains to give you augmented generation. We're using this for other things, right? Lots of different applications for this in healthcare, lots of different applications for this, obviously in education and also customer service, right? Because you might imagine an agent that's able to look at sort of a corpus that's from websites like files and websites resources to try and help a customer do some kind of functionality that they might need.
We're definitely using generative AI in our business operations here on campus. So one of my other working group leads in our generative AI solutions hub for Urbana campus is a guy who works for the sponsored programs office. And so he is, and to him, he's not replacing himself with technology. It's like it's accelerating his ability to answer complex questions about this grant or this contract or these terms and conditions or whatever. And there's a person who either has retired or is about to retire, and they put all of her, whatever, 500,000 emails from the last 25 years into our chatbot thing. And so you can ask it a bunch of questions, and he has tuned it so like it's really helpful. It's like she's going to retire soon and you have this weird question about cost accounting, and like it gives you a pretty good answer, or like what things to look at and stuff. So there are cases like that where it's like, yeah, it's like good decision support. And nobody's worried about, oh my God, we're taking over her brain or anything. It's just like, very practical and helpful. But again, he's a good wielder of the tool and he knows how to make it work.
Thank you. There was a question in the chat. I teach English writing and thinking to college freshmen. So far, AI seems to have made my job more difficult because it appears a shortcut. What am I missing?
Very good point. I have a confession to make. I use Grammarly a lot. And initially, I used it because I'm a very poor typist. And occasionally, I drop the S's at the end of a singular, first-person verbs, right? Or, whatever, third-person verbs. But then I realized something quite important. I write in the passive voice, right? Why? Because I'm an academic and an administrator. I just cannot say it straight the way it is anymore, right? Everything has to be circumvoluted, roundabout, and all that. Now, sometimes you have to say it that way. As an associate dean, I'm telling you, you really have to. Otherwise, there's hell to pay. But not always. There are times when I realize, man, I really have to say it, the way it is. So question is this: how can we turn this tool that teaches people how to cheat, right, basically, by infusing, synthetic language in their brains and putting, this synthetic knowledge out, to their disfavor? Because, the stuff that ChatGPT creates, after a while you realize it's kind of, it's worse than chicken, when it comes to dinners, right? It's like I can have it 1, 2, 3 times, but it really becomes predictable and boring, and not you at all, right? But at the same time, it can help you fix some of your bad habits, and can help you see, when you are too predictable or not creative enough, right? because, kind of brings you back to, whatever it thinks you should do. So I think that the question is, how can we turn these tools into scaffolding tools? That's the big question. It's not just a question of, bending the technology to do what we want, but how can we bend our teaching and evaluation methods, right, to bring us to that space where, humans and AI agents work together to say something better and write better.
I think, Soren, you're making a great point. And something that I always come back to this, there's a TED Talk that lives rent free in my mind, where after Ken Jennings lost Watson, he gave this TEDx talk where he was like, lamenting the fact that no one's memorizing, trivia facts anymore. Everything's just available to be searched online. And it's, kind of quaint, right? Like in retrospect, looking at this, right? It's a different form of knowledge and a different form of intelligence that you need when you have these other resources at your disposal. I think something that we've kind of found useful that I've been trying to integrate into my assignments is, I don't know if how you would do this for English, but maybe having a passage generated by the AI that has like some specific issues with it, and then having the students read it for correction to see what they could do. So we're, for example, thinking about having it try and generate a proof for like some well-known theorem, and then have the students go through the proof steps to be able to identify where the mistakes are and what it's making, right? Because that's how they're going to have to interact with the system in the wild as they're looking at these things, right? Really, the fundamentals here are thinking about, okay, what are the actual teaching goals of what we want to accomplish? And given that these technologies now exist, how do we supplement those? Right? Like we've taken out calligraphy now that we have Microsoft Word to type stuff on. Although I know some people do calligraphy as a hobby, right? So what do we do now that we have these methods that sort of help us jumpstart sort of drafts? Where do we focus the next set of skills on and use it as a scaffolding, like Soren said?
I think it's also interesting to look at the history of technology and how it has changed society, whether it's the invention of writing, meaning that we no longer need to memorize epic poems, or the invention of photography, which asks questions about what does it mean to be a painter. So, like, yeah, I think there's a lot of interesting questions there, and we're in this cusp right now of having to cope with this. I put in the chat the best practices for teaching and learning from the Illinois website. There's a lot of stuff. So the people on that working group, which is not mine, are from education, business, our Center for Innovation and Teaching and Learning. And a lot of what they have said echoes what we've heard here today, too, that it's not that you forbid this technology, but you have to like reframe what you want people to do with it and reframe your learning objectives. And there's a lot of interesting things that can be done. I think Neil deGrasse Tyson was on a talk show last year and said, well, maybe we need to go back to oral exams. But that doesn't scale up if you're teaching 600 kids, how to write an essay in an English class. But then you think about, well, how are we going to transform education to be much more personalized and have lots more, much lower ratio of students to faculty or whatever? There's a lot of interesting implications of that. But anyway, I think that the resource has a lot of good points about how one can look at trying to do these things.
Can somebody help me and remind me, what are the tests they use when they try to detect if a text was written by AI? Is it bursting?
Turn it in?
No. They are the two technical tests, the burstiness and perplexity. Is that? So the GPT-0, right, used two techniques. One was how unusual the words were and how unusually they were said in sequence or something like that.
Oh, I don't know.
Well, so when, this is generative AI detectors, right? They have some metrics. They use a methodology to tell you why, if this is an AI written text, and why it's written by AI. And typically, these measurements, boil down to the idea that AI generated texts are very predictable, right? They do not surprise. They do not take us out of a certain band of, words of a certain kind, right? And actually, if you think about it, we can use these techniques, right, in our assessment tools directly. Maybe at the moment when the students submit their their papers. I use Brightspace. We use Blackboard in the past, right? So I always ask the students not to attach files, but to submit the stuff in raw so that I could comment on it at the time. Now it turned it in that, what made it even more important. But, we can imagine tools, AI-based tools that can read the text in real time and give the student, an assessment of what they submitted immediately, right? That would not only tell them if this was likely written by an AI or not, but give them on the spot, advice relative to style and also to content. Your style is bland, your style is uninteresting, it's predictable. The content, uses, sources from here and there and there. And we would expect more from you. And in a way that actually the instructor would specify by setting constraints and spaces where the students need to look at. Again, I think that the AI revolution has brought with it, it has revived actually the machine learning, and should revive machine learning, make it into a very active way of teaching and learning. It's just that we have not expended enough money, us, the universities, have not spent enough money in this type of highly interactive, highly on the spot, just in time feedback, right? That can keep the student real and grounded, so to speak.
There was a comment in the chat that I wonder if folks would want to comment on. We have an epidemic of loneliness in this country, and this panel seems to be suggesting students interact with machines more.
Yeah, I think that one could think that, but I don't think we're actually saying that per se. It's just that there could be helpful tools to augment the, I was going to say like the relationship between the teacher, the lecturer, the professor, and the students. Now, again, if you think about higher ed, when one person is lecturing to 700 students, there's questions there about what kind of a relationship can one have. I enjoy reading the Reddit subreddit threads for our university where students are like, oh, which person should I take for, fluid dynamics or whatever? And sometimes the answer is, doesn't matter who you take because Professor so-and-so has these awesome YouTube videos. You can learn a lot from that. So just go there. So it seems like the technology mediated relationship, if you even can call it that, can be okay. It's like I want to learn something good and I have a great person to learn from on a YouTube, or I can read a good book about it. There's learning resources, that seems fine. But I do agree that we want to sort of foster authentic human connections. And so there's lots of ways to do that too. And of course, technology mediated communities are obviously a big deal, and many people rely on those as well. So I think it's a really great point, but I don't think we're advocating loneliness per se.
No, I don't think so. And unless any of my grad students are watching this, in which case you should keep working on your research. But all jokes aside, I think you raise a good point. But there are other interactions that students have, right, on campus as part of education that aren't just with the instructor, right? You can imagine technology mediated based interactions where then you encourage group activities, right? You say, okay, get together with a bunch of other people, watch this video, have a short writing assignment, and then have immediate feedback from the AI agent. It could be more decentralized, right? One instructor can interact with vastly more students potentially, right? The way you can design these systems. I think, obviously, right, I'm an engineer, not a psychologist. I do work with some psychologists, but it's not my area of expertise. I don't know what we could do to deal with a broader issue of loneliness. But I think there's more avenues, right, for folks to interact with life, right? Extracurricular activities, other functions of class, and not just with forming relationships with their instructors in terms of building community and campus and in education.
I will say, as a nurse, whatever you can do to use AI to deal with all the paperwork, I'd be very happy to then have more time to actually spend with my patients. So there definitely can be some positives to interacting with technology, hopefully. And to that end, we are nearing the end of our panel. I have one final question. What do you think is coming next in AI?
If
Well,
you could tell me, that'd be great. I could put it into my career award application and get some funding from NSF. But in all seriousness, I think there's a couple of things, right? Number one, it's going to become more prevalent, more easy to use. The APIs are getting better. We can ingest more varied data into LLM systems, including stuff with images, stuff that's no longer just black and white in different forms of text. You're going to see a lot more of that out there. You're going to see a lot more issues of parasocial relationships that probably folks are going to form with more sophisticated system. We had like the really tragic story of the teenager that formed a relationship with the chatbot a few weeks ago, then committed some grievous self-harm, and that's probably something that's inevitable. In terms of technology, though, I think we've got a long ways to go. I think there's the one direction which we're looking at, which is more kind of the GPT LLM direction of larger and bigger models that ingest more data to be applied broadly. But then the opposite direction, looking at stuff that's personalized, how do we use smaller sources of data that are concentrated on the individual more efficiently to be able to come up with useful predictions? Because we're not going to be able to train, a billion parameter model just using a stream of data that we produce from a single person. And yet, right, the recommendations that we could come up with for a single person are probably going to be more useful than something that's broadly at the population level. So that's going to be coming in probably, like we talked about some examples in education. Obviously, there's a lot of examples for this in healthcare, like note transcription. And then there's a whole other side of this that's more military applications that I'm not totally qualified to speak about. But that's, I think, some directions. And I'll let the other panelists say theirs.
It's very hard to predict what's going to happen next because, these advances in science and technology are made at the margins or the fringes in spaces that you could not imagine. These language models are the product of the lowly, work that people at Google did for many years, trying to figure out how to answer queries, how to answer questions, the questions that we typed in the Google boxes, right? They're trying to read our minds. Mixed with all this work on image recognition for figuring out who shared what picture when. But in terms of a wish list, what I wished we did more, and today and tomorrow for education especially. Jonathan mentioned smaller models. Actually, I would like to see more specialized, better curated models, right? Large language models are just that. They are models of our common language, of the common people speaking about common things. Oh, sure, they've been trained on Emily Bronte and Mary Shelley and Byron and all that. But by the end of the day, through regression to the mean, what they tell us are the banal, trivial things that any of us would say about banal, trivial things. Sometimes if we knew a lot of things. Now, how about, models that are in which the weights are biased in such a way that historical knowledge, right, is more accessible, better represented, and delivered in a way that is, that's been mapped by historians, right? Same with literature, same with, all the social and sciences and humanities, where, things are a little bit easier to deal with, because, these are kind of built into the language. The other thing that we need to figure out is how do we add to these language models logic models, right? And scientific models, right? Mathematical proofs, mathematical reasoning is not yet part of these language models. They're really bad at math, actually. They only tell you what they've seen done. If people, did something wrong, they'll give you the wrong answer, right? Stephen Wolfram, he thinks that he figured out a way to map, his Wolfram language and model with ChatGPT. Good luck to him. Maybe, maybe not. But we should not give up the good fight, right? Of trying to add all these things, to language models to make them smarter and make them better, right? Specialization, it's a must. We have only scratched the surface. And again, true innovation, we don't have a clue where that is happening right now. It might happening somewhere, in some place in India where some kid is trying to figure out something that we have not thought of yet.
I was just going to say that I thought, and to me, it's a likely course of action is that these tools that are now considered, the top of the line and very innovative will eventually fade into the background as, having a spell checker or Grammarly used to be like, oh my gosh, wow. It's like, nah, it's fine. So like to me, the our sort of acceptance of technology will it'll become permeated in our fabric of life, but that kind of depends on the three factors of the technology itself, what its capabilities are. Is it cheap or free to use? Because if it's expensive and arcane, then it's not going to get out there in terms of critical mass. And then is it culturally acceptable? So I remember when Uber first became famous, and I was like, when I was a kid, my mom would never have let me call some stranger up to give me a ride home. Like, what are you talking about? But oh, it's a company and they can be sued if they do something wrong, and we have their numbers and everything's tracked with the GPS. So now we have an infrastructure that says now we feel safe. So I do think, and then here on campus, I've talked to some of my directors about, certain incidents that we've seen on campus. And one of our conclusions is that we're seeing a lot of after effects of the pandemic itself. Like people are still kind of shy and they haven't, my current sophomore in college here went through high school during the pandemic and didn't really get to do any real chemistry because you had to be on Zoom. So they ended up doing a lot of physics problems instead of actually being in the lab. So now taking chemistry here is like really painful. So again, without having some access to some of those experiences, it makes it harder to deal with. And I think it's interesting that two of my kids are really uninterested in social media and AI. My youngest kid is like, it's a dumb remix. I don't care. So again, I think that there's a lot of other, kind of factors at work, and it may be a generational thing about how people decide to accept or not accept certain things.
Right. Well, I would like to thank all of our panelists for a wonderful discussion, and I'll turn over to you, Greg, to close out the conference.
Yeah, thanks, Kristen, very much. Thanks all the panelists. Very, very nice discussion. Really good questions were asked, and I think nice feedback offered. And so your perspectives are most appreciated.